Earlier, in the USSR, bricks were fired in gas kilns. Later, the gas pipes were cut, and now in our country, it is only possible to shovel coal, peat, or pellets by into the former holes of industrial gas kilns, hoping that the stoker would not fall asleep or get drunk. I devoted 2 years of my life to the topic of brick firing with generator gas. I personally made a list and called all operating and non-operating brick firing plants. I read about 100 books on brick firing in both circular and tunnel kilns, including gas firing. The first brick firing kilns used generator gas. In general, the entire industry in our country in the West started with generator gas. Back then, nobody has even heard about pipe gas or propane butane, a product of oil refining. These gases began to be used much later. I read a German book from 1902, which showed how to fire bricks with generator gas in a circular kiln. There was a diagram of the gas distribution and plant operation. When the USSR began to build the first brick-firing tunnel kilns, they all ran on generator gas. I had to dig through about 100 books to figure out how everything worked and how the generator gas was produced and fed into the kilns. Why was I looking for this information? Because generator gas is not gasoline, it can't be stored. One of the best ways to use it is ordinary clay brick firing. I wanted to establish my own generator gas brick kiln plant for several years. By the way, I invite anyone who wants to cooperate. I even found a plant for 120,000 bricks per day, 120 kilometers from the capital. I did not manage to buy it, but the estimates were very promising. About 1 kilowatt of thermal energy is spent to fire one brick. Gasification of 1 kilogram of wood or agricultural waste can produce 3.7 kilowatts of thermal energy. Energy comprises 60% of the brick firing cost before the crisis in gas wars. Things are much worse now. Even earlier, the plants couldn't operate and the industry was dying. Now it is probably as dead as a doornail. I have seen dozens of plants, and I have called hundreds. The reality of the industry for me came together in a clear picture from talking to hundreds of owners, CEOs, and engineers. The picture is as follows. Bricks are fired in kilns with whatever the owners manage to get. Shovels are used to put coal of different brands, whichever can be found. All of this is done in an artisanal way. There's a man to walk around a kiln, look in the holes and determine by eye how much coal or something else to shovel. This person needs to be trained. And there are no technologists left, so every Tom, Dick, and Harry can work there. They might not shovel enough coal or shovel too much, get drunk and fall asleep, not go to work, or misjudge the temperature of bricks in a kiln. By the way, the latter happened all the time because the locals who did escape to a city or abroad were mostly local alcoholics. The eternal scourge of all brick plants is personnel shortage. As an owner of 3 circular kilns told me, first, we didn't take those who drink, then we started taking those who drink, and then there was a shortage among those who drink. I witnessed a situation at one tunnel plant in Nemirov where a worker shoveled too much fuel. It fell between the cars and ruined the rails and cars, leading to tens of thousands of dollars in repairs and a year of downtime. Another worker just got drunk and fell asleep, and the bricks didn't get burned. This way of firing by eye with a shovel leads to defects, overdash, or underburned bricks. It also leads to painful dependence on 3 men in the firing shift who can do any nonsense. Moreover, it leads to unnecessary payments to employees who could be replaced by automatics and gas burners. Only modern operational plants, bought for tens of millions of dollars, have automatics and gas burners. But there are very few of them. All the other plants are either surviving on the verge of masochism or are simply sold. The industry was dead already 10 years ago. The main reason was high fuel cost. And there are even problems with coal. Sometimes the coal bought is just dyed rubble. Or coal with high ash content. How can coal quality and ash content be determined by eye? To summarize, the answer to why the industry is dead is expensive and low-quality fuel as well as artisanal ways of firing by eye. Now let's talk about generator gas as a fuel for brick firing. As I have already said, 3.7 bricks can be fired with 1 kilogram of wood turned into gas. How much is brushwood? or slab wood from sawmills. Besides, it can be mixed with plastic garbage, bags, yogurt bottles, and motor oil cans. Only plastic bottles should be picked up from the household waste thrown into landfills. The rest of the plastic goes into the ground. Today, garbage is all plastic packaging. Think about what you're throwing in a waste bin. Very good gas could be obtained by mixing this waste with wood in a gasifier. 1 kilogram of polyethylene bags almost equals 4 kilograms of wood in calorific value. 1 kilogram of wood makes 3,500 kilocalories, 1 kilogram of bags makes 12,000 kilocalories, and 1 kilogram of gasoline makes 10,500 kilocalories. Fuel consumption is also worth mentioning. Gasifiers are always up to 30% more economical than conventional combustion. That is, turning fuel into gas in a gasifier reduces fuel consumption by 30% compared to direct throwing the fuel with a shovel into a kiln. The second advantage of generator gas for brick firing is flame temperature and flame propagation speed. Natural gas burns at 1,600 degrees while generator gas burns at 1,100 degrees. Bricks are fired at about 900 degrees. While I designed tunnel furnaces to convert them to generator gas, the main problem with natural gas burners was flare sharpness. Bricks are literally cut because natural gas burns as high as 1,600 degrees. This is why technologists try to aim a gas flare not at bricks but at the space between brick cars not to spoil raw material. Generator gas does not have this disadvantage. It will not burn bricks. The flare burning speed is also important. Technologists place a large number of burners on the top of a kiln and try to keep gas flares long for the natural gas burner heat to reach the middle of a stack of fired bricks. This helps heat reach the middle of the bricks in a stack, not only the top layer. It is reasonable to lay the bricks with gaps to let the heat propagate in there, too. Burners are made with a small diameter to make their flares longer. Generator gas gives a long flare. It can be up to 5 times longer than natural gas flare, so due to its low temperature and length, it sort of envelopes bricks, gently releasing heat and space rather than overheating the bricks in a small spot like natural gas. Once again, natural gas heats one localized spot. Generator gas does not give as high a temperature, and the heat spreads over a much larger space, penetrating gently into a stack of bricks. When I dreamed of owning a brick factory, I gathered a team of technologists who had developed automated tunnel kilns. I had to endeavor and find old Soviet scientists. That is, I made and installed burners, and they make all the automation with thermocouples and computer control. They had many years of practical experience in converting tunnel kilns to gas. In other words, we developed a full-fledged generator gas plant with automatic control. This immediately made it possible to do without a large staff of stockers. I have been to several tunnel kilns and made several designs to convert them to generator gas, but I didn't get a chance to practically implement the designs. I did not manage to become a part owner of such a plant at that time, although I really wanted to. But you never forget how to ride a bike. You can call me on WhatsApp for a partnership or order a design of conversion of a tunnel or circular kiln to generator gas.